KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Good morning, students. In this session, we are going to continue last class information. Already in my previous session, already completed different type of the hybridization. Sp hybridization, Sp2 hybridization and Sp3 hybridization along with the example. Now in this session, we are going to discuss another important hybridizations. Number one is the Dsp2 hybridization and Sp3d hybridization and Sp3d hybridization. These three hybridizations are very important, especially Dsp2 hybridization is very important, especially in the coordination compounds. So now similarly, inorganic compounds point of view, Sp3d hybridization is very important, and also Sp3d hybridization is also very important in the inorganic compounds point of view. And later, how to determination of the hybridization concept, what are the formulas are available or what are the formulas are used, the complete information we are going to discussing in this session. So the first one is Dsp2 hybridization. So what is the Dsp2 hybridization? The orbital involved in the Dsp2 hybridization, one d orbital, especially dz orbital from the p orbital. So dz orbital, one s orbital, two p orbital are intermixing. So one d orbital, one s orbital, two p orbital are intermixing, then form four different type of the new hybrid orbital. Such kind of the hybridizations of the molecule generally existed square planar structure. The bond angle is 90 degrees bond angle. So the best example, dichloroplatinum ammonium. So dichloro-diammonium platinum, the best example. It is a coordination compound. Okay ma? So Dsp2 hybridization point of view, the molecule can show the 90 degrees bond angle with square planar structure. It is a best example, best hybridization process in the formation of coordination compound. Now second one is Sp3d hybridization. It is a very important hybridization in inorganic compounds as well as the coordination compound also. Now here Sp3d hybridization means one s orbital, three p orbital, one d orbital are intermixing. One s orbital, p3 orbital, one d orbital are intermixing or to combine to give 5 identical orbital. Because of the one s orbital, 3 p orbital, 1 d orbital are intermixing na, there are 5 different type of Sp3d hybrid orbitals are formed. It's nothing but new hybrid orbitals are formed. sp3d new hybrid orbitals are formed. எப்போ ஒரு s orbital 3p orbital 1d orbital are intermixing na 5 different identical sp3d hybrid orbitals are formed. Such kind of the hybridization, the bond angle possible in sp3d hybridizations are 90 degrees or 20 degrees 120 degrees bond angle. Because of any one of the molecule are involved in the sp3d hybridization, it show two different type of the bonds, bond angle. One is the axial bond, one more equatorial bond. Axial bond showing one kind of the bond angle, equatorial bond are showing one more kind of the bond angle. That's why whenever any one of the molecule involved in the sp3d hybridization, it has two different type of the bond angles. Number one, 90 degrees bond angle. Number two, 120 degrees bond angle. In the sp3d hybridization, equatorial bonds are there and axial bonds also present here. But in this hybridization point of view, so what is the percentage involvement of the s orbital, p orbital and d orbital na? S orbital just only 20% is involved, p orbital just only 60% is involved, d orbital only 20% is involved. It's nothing but in the sp3d hybridization point of view, orbital will have 1 by, especially s orbital 1 by 5th part, it's nothing but 20%, and p orbital 3 by 5th, so it is a 60%, and d orbital 1 by 5th, it is also 20%. So s orbital 20%, p orbital 60%, and d orbital 20% are involved. And one more important key point in this hybridization point of view, central atom in a molecule having trigonal bipyramidal shape, if any one of the molecule can existed sp3d hybridization without lone pair of the electron, such kind of the molecule can existed trigonal bipyramidal shape. The best example is the PCl5. The best example is the PCl5. In the PCl5, phosphorus bonded with 5 chlorine atom without any lone pair of the electrons on central atom of the phosphorus, then can exist a trigonal bipyramidal shape. Now we are going to discuss the PCl5 formation, how they are formed the PCl5. Now phosphorus atomic number 15. So the general electronic configuration 1s2, 2s2, 2p6, 3s2, 3p3. Its valency shell s orbital has 3s orbital has 2 electron, 3p orbital has 3 electron, 3d orbital there is no any electron. Epo at ground state of the phosphorus, at ground state of the phosphorus, 3s orbital only 2 electron, 3p orbital only 3 electron. But here total unpaired electrons 3 at ground state on phosphorus. On phosphorus only 3 unpaired electrons. But here 5 chlorines are approaches to the phosphorus. Apo 5 electrons are required. But phosphorus at ground state level, it has only 3 unpaired electrons. Apo phosphorus at excited state, from the 3s orbital, one electron jumped into the d orbital. One electron jumped into the d orbital. Now we will see here. Apo one s orbital has only 1 electron, p orbital has 3 electrons, and d orbital has 1 electron. So 5 unpaired electrons are present right now. 5 unpaired electrons are present right now. That 5 orbital with the unpaired electron, 5 orbital are intermixing na. One s orbital, 3p orbital, one d orbital are intermixing na. Apo 5 different type of the new hybrid orbitals are formed. So sp3d such kind of 5 category of the new hybrid orbitals are formed. Right now this 5 hybrid orbital bonded with 5 chlorine atom like this one. 5 new hybrid orbital bonded with 5 chlorine atom, hence to form the trigonal bipyramidal shape. Hence to form the trigonal bipyramidal shape. This is the structure of the PCl5 molecule. Here important point enna, at ground state level phosphorus having only okay ma. Now here from the phosphorus at a ground state level it has 2 s electron, 3 unpaired electron in the p orbital. There is no any d electron, but in the excited state NH na, from the 3s orbital 1 electron jump into the 3d orbital. 1 electron jump into the 3d orbital. It can arrange it as a phosphorus 5 unpaired electron in the s p3 and d orbital. s p3 and d orbital. Now over s orbital 3 p orbital 1 d orbital are intermixing na, ellame intermixing na, appo 5 new hybrid orbitals are formed. That 5 new hybrid orbital bonded with 5 chlorine orbital. 5 chlorine orbital, hence the molecular shape can exist at trigonal bipyramidal shape. So now right now this was the PCl5 structure, trigonal bipyramidal shape. The trigonal bipyramidal shape. This is the Sp3d hybridization. Generally without any lone pair of the electron, Sp3d hybridizations of any molecule, 0 lone pair of electron to show trigonal bipyramidal shape. The best example is the PCl5. Now one more example, Sp3d2 hybridization. It's one more hybridization, Sp3d2 hybridization. Now here how they are formed na, one s orbital 3 p orbital 2 d orbital are intermixing. One s orbital 3 p orbital 2 d orbital are intermixing na, appo 6 new hybrid orbitals are formed. 6 new hybrid orbitals are formed. So here the bond angle of the bonds, in between of the bonds, the bond angle 90 degrees bond angle, but here 6 orbital are involved in the hybridization. The percentage how to calculate it na, s 1/6 part, s is the 1/6 part, and p 1/2 part, d 1/3 part is involved. 1/3 part is involved. The best example is the SF6 molecule. SF6 molecule. But now here SF6 molecule showing octahedral manner. Octahedral manner because of there is no any lone pair of the electron. In SF6 the central sulfur atom has the ground state electronic configuration. Now see here the sulfur atomic number 16, ground state electronic configuration enna 3s 3p 3d da. So 3s orbital have 2 unpaired electron and 3p orbital 2 paired electron in the px, 1 py, 1 more electron in the pz, unpaired electron. In the 3p only 2 unpaired electrons are there. Only 2 unpaired electrons. But 6 fluorines are approaching to the sulfur. Right now sulfur can arrange the 6 unpaired electron. But at ground state NiH only 2 lone pair of electrons are present here. Now what happened na, from sulfur atom, from the 3s orbital, this 1 electron jump to the 3d and also 3p orbital, 1 more electron jump to the 3d. Appo d orbital has 2 unpaired electron and p orbital has 3 unpaired electron, s orbital has 1 unpaired electron. அப்போ எல்லாமே this s orbital, this p orbital, this d2 orbital are intermixing na total 6 new hybrid orbital is formed. After new 6 new hybrid orbital is formed na every fluorine atom connected with one new hybrid orbital. So finally SF6 structure is formed. In the SF6 structure, sulfur there is no any lone pair of electron because of it has group 16th family, but it has only 6 electron. 6 electrons are involved in the 6 fluorine atom. Appo structure is octahedral manner. Octahedral shape is formed. Octahedral shape is formed. Now here at ground state the NiH na in SF6 the central sulfur atom has the ground state outer electronic configuration 3s2 3p4. In the excited state the available 6 orbital, that is 1s 3p and 2d are singly occupied electron. This orbital hybridization to form 6 new sp3d hybrid orbital which are projected towards the 6 corners of the regular octahedral manner in SF6. This 6 sp3d hybrid orbital, this 6 sp3d hybrid orbital with singly occupied orbital of the fluorine atom to form 6 SF sigma bond. Thus the SF6 molecule has the regular octahedral geometrical manner is existed like this one. This is the octahedral shape of the SF6 molecule. Octahedral shape of the SF6 molecule. So this is the sp3d hybridization. The most important thing is in the sp3d hybridization lo oru s orbital 3 p orbital 2 d orbital are intermixing. There are 6 new hybrid orbital are formed. The 6 new hybrid orbital again bonded with 6 fluorine atom, hence to form the octahedral manner. Hence to form the octahedral manner. Now I successfully completed the entire hybridization concept of the molecule sp, sp2, sp3 and sp3d d2 sp hybridization, Dsp2 hybridization and sp3d and sp3d2 எல்லாமே completed. Now we are going to discuss how to determination of hybridization. There are different type of the formulas are available. You can calculate anyone calculate the hybridization, but now here one important formula, determination of hybridization, shape of the molecule having single central atom. So now EP is equal to S plus half into G minus V plus A minus C. Inga EP is nothing but electron pair and S is nothing but number of the shared pair electron. Number of the shared pair electron. G is nothing but group number. G is nothing but group number or number of the valence electron. Group number or number of the valence electron is nothing but G. V is nothing but valency of the central atom. What is the valency of the central atom? V, valency of the central atom of the compound. And A is nothing but C is nothing but charge of the cationic, and A is nothing but charge of the anion. Now with the help of this formula it can easily do determination of the hybridizations of molecule. Now here one example is there, CH4 molecule, methane molecule. So methane can show sp3 hybridization. It's tetrahedral manner. Because of the methane there is no any lone pair of the electron. There is no any lone pair of the electron. It's only bond pair of the electron. 4 bond pair with 109 degrees 28 minutes and tetrahedral manner. That's why the shape of the molecule tetrahedral and sp3 hybridization. How to calculate it? First one, s. S is nothing but number of shared pair electron. So carbon bonded with 4 hydrogen atom, carbon bonded with 4 hydrogen atom, appo number is the 4 the plus half. Here formula lo half irukku. After that G. So G is nothing but group number. So carbon is belonging to the group number 4. It is nothing but 14th group. So 4 minus group number minus valency electron 4 the. So there is no any anion or cationic. There is no any anion or cationic. So overall the value we should be 4. 4 is nothing but sp3 hybridization. sp3 hybridization. So with the help of this formula you can easily to calculate the hybridization concept. Can easily to calculate the hybridization concept. In my next class we are going to discuss the hydrogen bond.